Hello, this is Vardhan. Today we are going to discuss 2012 question. So let's see the question. So 4-point charges minus q, 2q and plus 2 capital Q are placed at each corners of the square. The relation between capital Q and small q, for which the potential at the center of the square is 0. Okay, so the situation will be like this. They have given 4 charges, minus q, and 2q, like this, and they placed each charge at these corners of a square, and the distance of the charge from the center, let's assume it's equal distance as r, and the conditionally is mentioned that the potential at the center of the square is 0. Then we need to find out the relation between capital Q and small q. So the net potential at the center, that's what V is equal to the potential due to first charge plus potential due to second charge, the potential due to third charge, and the potential due to fourth charge. So therefore the resultant potential will be 0 at its center of the square, and because of minus charge, V1 will becomes K minus Q by R, and V2 will becomes minus, this is minus K Q by R, and because of this charge K to Q by R, and because of this charge that will be V4 plus 2Q by R. And on simplification, this K and R we can take common, and remaining will be minus Q minus small q plus 2Q and plus capital 2Q, that is equal to 0. So now, so minus Q and plus 2Q, then it will become plus Q, and minus capital Q and plus 2 capital Q will become 1 capital Q, then that is equal to 0. Then therefore capital Q is equal to minus Q. So right option is the first one. Okay, so next we will see next question. In 2003 they are asked 2 pith balls carrying equal charges are suspended from the common point by the string of equal length. The equilibrium separation between them is R. So now the string is rigidly clamped at half the height. The equilibrium separation between the balls becomes. So this is the situation. So they have given 2 pith balls. The conditionally at first case, 2 pith balls are clamped at the point, and the lengths are same, charges are same. Okay, charges are also same. Okay, and suspended to height says 1. So then separation between them will take R. So now you know very well. So this is having some charge, and this will have some charge, and there is some repulsive force F, and because of a mass mg will adds. So therefore here there is a string. Okay, tension will add for this tension will result into 2 components, as since it makes an angle theta, that is, this will be t cos theta and this will be t sin theta. Especially let's solve this figure in this case. Okay, so t mg mg, it is balanced by t cos theta, and f, which is balanced by t sin theta. F, which is balanced by t sin theta, mg is balanced by t cos theta. When divide these two, what will get? Or let's take equation 1, and this is as an equation 2. So when you divide equation 2 by 1, we'll get, it's a tt will get cancelled when take a ratio. Then sin theta by cos theta, it will becomes tan theta. Then that is equal to what? It is f divided by mg. Now tan theta, so you can define from this figure, it is in vertical side, or let's take it's an opposite side, and this is an adjacent side. So opposite side will be from here to here. Since from here to here will take r separation between the two pitfalls. Half of that, it's an r by 2. Therefore opposite side will be r by 2 all divided by is an adjacent side, that will be y. Then that is equal to, so what is f? This is the repulsive force between the two point charges. That's what Coulombian force, k q square divided by it's an r square all divided by it is mg. So then I will take it as an equation 3. Similarly, so when conditionally, what they are doing here, now the string is rigidly clamped at half the height. Then the equilibrium separation between the balls now will becomes, so when the height is reduced half of its original value, what may be the equilibrium separation between these two pit balls? We need to find out r. The distance between the two pit ball will be r dash. We need to find out r dash. Let it be, this is the second case. In the second case, see the figure. Okay, so again we can define tan theta in same manner as we done here. Okay, tan theta is equal to, f divided by mg. So then you just define tan theta, it is an opposite side divided by adjacent side. Opposite side will be r dash by 2 all divided by adjacent side, it will be y by 2. Then that is equal to, so f here is a k q divided by the distance between the two pit balls. It is now, it will becomes r dash square, then all divided by remainder, it's an mg. Then I will take it as a equation 4. Now just divide equation 4 by 3. So when you divide these two on simplification, what will get? So r dash by 2, and I can in simple manner I can write it as 2 by y all divided by, in equation 1, r by 2, it is y means it is a 1 by y. Then that is equal to, on right hand side everything is will get cancelled. mg will get cancelled, kq square will get cancelled. Only is that it's 1 by r dash square all divided by 1 by r square. Then just cancel out, it's in your 1 by 2 will get cancelled. This 2 will get cancelled. y will get cancelled. Only 2r dash will get remaining, and to r dash. So when I bring this r dash into, and on simplification, what we'll get on rearranging this one, so we'll get, so this r dash square will go into this side, then it will be r dash cube, then that is equal to this 2 will be there, this 2 will be there, so and r will be there, so remaining it is in r cube divided by 2. Is that clear? So here r square is there. When I bring this r square, it will become r cube, and this r dash square, when you take this side, it will become r dash cube. Okay, when you take a cube root on both sides, okay, so when you take cube root on both sides, remaining r dash, then that is equal to r divided by cube root of 2. So r dash will be r divided by cube root of 2. Right answer is so r divided by cube root of 2. R divided by cube root of 2. So right answer is r divided by cube root of 2. Okay, so we'll see the discussion in next session.